Good morning, grade 9, and we're going to continue our lesson, chapter 5, lesson 1 in Algebra 2, variation functions. We started the lesson yesterday and we're going to continue the lesson today. We learned yesterday a direct variation. A direct variation is a relationship between two variables, x and y, that can be written in the form y is equal to kx, where k is not equal to 0. In this relationship, k is the constant of variation. And when x increases, when x increases, y increases. And we solved some exercises yesterday. Today we're going to learn another kind of variation, which is a joint variation. A joint variation. What is a joint variation? A joint variation is a relationship among three variables that can be written in the form y is equal to kxz, kxz, where k is the constant of variation. For the equation y equal kxz, y varies jointly as x and z. Okay, girls, let's watch a video now.
Hey, here's a fun one. Let's take a look at this one together. The area A of a triangle varies jointly as the base themselves. So the area, which in this case is the y, 20, equals k times the base, which is 5, times the height, which is 8. And so I see that 20 equals 40k. Divide both sides by 40 to get the constant alone, and we see 20 over 40, which is 1/2. So k equals 1/2. Are you surprised? Absolutely not, because of course we know the area for a triangle. Area equals 1/2 base times height. So in fact, we're just finding something that we already knew, but now you can see how we can really find it, and that this is really a joint variation hidden. So now we see that the area A is 1/2 the base times the height, and we just found that for ourselves, realizing that we have a joint variation. Question at hand is, find B when A equals 60 and H equals 6. Well, now this is not really that big of a deal. We know that A equals 60. We know that H equals 6. I don't know what B is, though, and so I see 60 equals 3B, or not 3B. I guess it only works with 2B. 2B or not 2B. Not 3B, not very funny. All right. Divide both sides by 3, and I see that B equals 20. So what are my units? The base is 20 meters. So you can see it's sort of cool that we can actually use this notion of joint variation to confirm the formula for a triangle. The constant in that case is 1/2.
Okay, girls, let's answer number 3 here. And the lateral surface area L of a cone varies jointly at the base R and height L, and the height L and L equals 63 pi m squared, where R is 3.5 and L is 18. Find R to the nearest tenth when L is 8 and L is 5. So first of all, I have to write the variation function here. So surface area L equals K varies jointly as the base R and height L. So it varies with R and L, small l. So when L is 63 pi, I don't have the pi sign here, so let me call it, I will give it here the sign. For example, I will write it hash as if it is pi, because I don't have it now. The sign is not available for me to write it here, so I will give it hash as if it is pi. Okay, girls, equals to K multiplied by R, which is 3.5, multiplied by L, which is 18. So 63 multiplied by the value of pi, which is 3.14, equals to K multiplied by 3.5 multiplied by 18. 3.5 multiplied by 18 is 56.7. So again, let me multiply the other side, which is 63 multiplied by 3.14, which is 197.82, equals to 56.7 K. So if I divide both sides by 56.7, so K is equal to 197.82 divided by 56.7, so K is equal to 3.48. 19.7. Okay. So now I got the value of K. Okay, girls. So now I'm going to repeat again the function L equals to K multiplied by R multiplied by L. So I want to know R to the nearest tenth when L is equal to 8 pi. So L is equal to 8 multiplied by 3.14 equals to K, which is 3.48 times R that I want to know times L that is 5. So when you multiply 8 by the value of pi, which is 3.14, and in the other side you multiplied the value of k and the value of L, that is 5, then finally you will get R. Then you have another kind of variation, which is called inverse variation. What is inverse variation? Inverse variation. The third type of variation describes a situation in which one quantity increases as the other decreases. For example, the table shows that the time needed to drive 600 miles decreases as the speed increases. As we know that when we increases the speed, the time decreases. If we want to go fast, we want to reach on time, we increases the speed, so the time will decrease, so we will arrive on time. This type of variation is an inverse variation. An inverse variation is a relationship between two variables, x and y, that can be written in the form y equals k over x, not multiplied by x, but it is k over x. It is k over x, where k is not equal to 0. For the equation y equal k over x, y varies inversely as x, inversely, not directly, inversely. Y increases when x decreases. Let's watch here a video.
In some sense, the opposite, if you will, of
Okay, girls, let's go to the second page. Next page. Here we have given, example 4, given y varies inversely as x, inversely, and y equals 3 when x is equal to 8. Write and graph inverse variation functions. Y is equal to k over x. K over x, not k multiplied x, because it is inversely, varies inversely. So I'm going to, first I want to know the value of k so I can write the function correctly. So I know the value of y, so I'm going to substitute its value. Y is equal to 3 and x is equal to 8. So k is equal to 3 multiply 8. So it is equal to 24. Y is equal to 24, 8. So what are the steps that I'm going to follow? I want to get the value of k so I can write the function correctly. How I'm going to get the value of k? I will substitute the value of y and I will substitute the value of x. The value of y and the value of x are given here. So y is equal to 3, x is equal to 8. So now I can get the value of k. K is 3 multiply 8, which is 24. Then I'm going to graph. I'm going to give some values for x, negative 3, negative 4, negative 8, negative 12, and the same values but positive. Negative 3, negative 4, negative 8, negative 12, and the same numbers but with positive signs 3, 4, 8, and 12. Then I'm going to substitute for x is negative 3 here, then I'm going to get y. X is negative 4, I will put it here, 24 over negative 4. Then x is negative 8, I'm going to substitute x by negative 8 to get y. I'm going to substitute x with negative 12 to get y. Again here, I'm going to substitute x with 3. I'm going to get the same answers but with different signs. Here, let's solve another one. Here, y varies inversely as x and y is equal to 4 when x is equal to 10. Write and graph the inverse variation. Y is equal to k over x. I want to get the value of k so I can write the function correctly. I have the value of y and I have the value of x. Y is equal to 4. So 4 is equal to k over x. X is equal to 10. So k is equal to 40. So now I can write the function y is equal to 40 over x. Then I'm going to choose some points, for example, like the points that I have here, the same like up here, negative 3, negative 4, negative 8, negative 12, and the same 3, 4, 8, 12, and substitute them here, please. By x is negative 3. X, by the way, you can change. You can choose, for example, negative 2, negative 4, negative 6, negative 8. You can choose any numbers that you want and choose their opposite signs. Okay, so take here another numbers. You can choose, for example, here like negative 2, negative 4, negative 6, and negative 8. So I will give you the points here that you're going to choose. Choose negative 2, negative 4, negative 6, and negative 8. And choose 2, 4, 6, and 8. So you're going to substitute x by negative 2 and find y. So it will be 4 over negative 2. Then 4 over negative 4. Then 40 over negative 4. 40 over negative 6. 40 over 8. Negative 8. Left for us The last variation, which is called combined variation. Combined variation. Here it is. Where is the combined variation? Yes, here it is. A combined variation is a relationship that contains both direct and inverse variation. Quantities that vary directly appear in the numerator, and quantities that vary inversely appear in the denominator. Again, quantities that vary directly appears in the numerator. So directly will be in the numerator and inversely will be in the denominator. Okay, girls, let's watch here a video.
Let's take a look at a real-world example where we can see in actual everyday events.
Not this one.
We have an inverse variation or a direct variation. Let's take a look at some examples and see if we can classify what we would say the data is conforming to. So here I see x's. See if in fact we have an inverse variation.
Okay, girls, so today we have learned all the kinds of variation. So see you tomorrow and don't forget to answer your homework. Thank you.